Today we are learning how to solve higher order homogeneous linear ODEs with constant coefficient. The general form of such an equation is an d raised to n y by dx raised to n plus an minus 1 d raised to n minus 1 y by dx raised to n minus 1 plus etc. up to a1 dy by dx plus a naught y equal to 0, where an minus 1 etc. up to a naught are constant and n is the order of the ODE. In order to find the solution, first step is to form the characteristic equation by replacing the derivatives with the powers of m. Then we need to find the roots of the characteristic equation. Then we need to write the general solution based on whether the roots are distinct, repeated or complex. If the characteristic equation gives us distinct real root, then the general solution is y of x equal to c1 e raised to m1x plus c2 e raised to m2x plus c3 e raised to m3x plus etc. up to cn e raised to mnx. If the characteristic equation gives us repeated roots, then the general solution is y of x equal to c1 e raised to mx plus c2x e raised to mx plus c2x square e raised to mx plus etc. up to ck x raised to k minus 1 e raised to mx. If the characteristic equation gives us complex root, then the general solution is y of x equal to e raised to alpha x into c1 cos beta x plus c2 sin beta x. Now let's solve some questions. The first question is d cube y by dx cube minus 2 d square y by dx square minus 5 dy by dx plus 6y equal to 0. To solve this question, first we need to write the characteristic equation, then we need to find the roots. In this question the roots are minus 2, 3 and 1, which is case 1. So the general solution will be c1 e raised to minus 2x plus c2 e raised to 3x plus c3 e raised to x. And the second question is y 4 dash minus y equal to 0. First write the characteristic equation, m raised to 4 minus 1 equal to 0. Here we can write the m raised to 4 as m square all square. So the equation will become m square all square minus 1 equal to 0. We can rewrite the equation as m square minus 1 into m square plus 1 equal to 0 using the identity a square minus b square equal to a minus b into a plus b. So the roots will be plus or minus 1 and plus or minus I, which is the combination of case 1 and case 3. So the general solution will be c1 e raised to x plus c2 e raised to minus x plus e raised to 0x into c3 cos x plus c4 sin x. The third question is y 4 dash plus 2y double dash plus y equal to 0. First we need to write the characteristic equation, that is m raised to 4 plus 2m square plus 1 equal to 0. Here we can replace this equation in the form of quadratic equation. So the equation will become m square all square plus 2m square plus 1 equal to 0, and the roots will be plus or minus I and plus or minus I, which is a combination of case 2 and case 3. So the general solution will be e raised to 0x into c1 plus c2x cos x plus c3 plus c4x sin x. And the last question is y triple dash minus 8y equal to 0. First write the characteristic equation, that is m cube minus 8 equal to 0. Then using trial and error method we can find the roots. Trial and error method is basically substituting trial values into the characteristic equation until it satisfies the equation. The value which satisfies the equation will be one of its root. Here 2 satisfies the equation, so it is one of its root. Using 2 we can find the other two roots by synthetic division. So here the final roots are 2, minus 1 plus or minus root 3i. So the general solution, which is a combination of case 1 and case 3, so the general solution will be y of x equal to c1 e raised to 2x plus e raised to minus x into c2 cos root 3x plus c3 sin root 3x.